The paper's front cover image of 24 lines and 25 dots is derived from a solution to the Riemann hypothesis using three-dimensional mathematics. I discussed this solution in another video and briefly in this research paper. But thanks to this P equal NP mathematical breakthrough, there are now 84% to 99% better odds for lottery players using unique winnable sets that come from three-dimensional mathematics. These mathematically proven improved odds now make it easier to win at lottery games. Let's look briefly at the front cover of the mathematical proof paper. Please find first cause intelligence. Earlier, I stated that artificial intelligence is made obsolete by three-dimensional mathematics. Artificial intelligence is made obsolete because of first cause intelligence. First cause intelligence is based on one energy that cannot be created nor destroyed and three dimensions of space, 1 and 3. Notice the 3 as far as three-dimensional mathematics is concerned. The 3 dimensions of space, a mathematical formula, which is called three-dimensional mathematics now, has never been applied to the 3 dimensions of space. So when Albert Einstein gives us 1 dimension of time and 3 dimensions of space, he is in fact stating first cause. There is no other reality other than 1 energy and 3 dimensions of space. The logical question mathematicians and scientists will have is, if we have 1 energy, where did these 3 X, Y, Z axes come from? For your thinking about this problem, those X, Y, Z axes or variables could only have come out of 1 energy, 1 time. 1 time and 1 energy with first cause are one and the same. I spoke briefly about 7 problems that were presented, that are presently in mathematical literature as being the 7 most difficult problems in mathematics to be solved. One of those problems is called P equal NP. And the next slide after this brief, I will show an example of the mathematical proof of the P equal NP. These 7 prizes were made available by the Clay Institute, offering a meager prize of $1 million for each one of these solutions. One of the 7 problems has been solved already by a Russian mathematician. This Russian mathematician refused this prize and he refused to be interviewed. He's a pure mathematician. So any of the mathematicians who have ever been around pure mathematicians, they seem to be a little odd because they focus so much on the problems they're looking to solve. Now the reason I mention the word meager, anyone who's watching this presentation and anyone who says, okay, now we have a new mathematics called three-dimensional mathematics, why in the world would someone sell that type of information for $1 million when it's worth trillions and trillions and trillions of dollars? It doesn't mean that one individual is going to be worth trillions and trillions and trillions of dollars. What it means is that all of the technology that we deal with right now, all of the science that we deal with right now, all of the people working in these arenas are going to have to upgrade their mathematics to include three-dimensional mathematics. The body of knowledge in all of mathematics, all of science, and all of technology will have to be upgraded to include three-dimensional mathematics. Computer systems and educational textbooks must be covered in this upgrade. The implications are simply huge. There are 2 slides in this presentation that would be and should be of importance for mathematicians and for lottery players as well, because as we see or saw that all lottery games depend on the formula n factorial over d factorial. No matter how simple this formula looks, n factorial over d factorial. We are dividing a number, the denominator and numerator. We're relating the two for a ratio. But now what we find is that that formula is incomplete. The number that we divide, when we say n factorial divided by d factorial, the number that we get is true. It's absolutely a fact. But the problem is, it's only one number. What three-dimensional mathematics says is that there are n number of groups embedded in that calculation that comes from the denominator. In this slide here, you see a familiar structure. The same format that was used earlier of n factorial divided by d factorial was used to solve this problem here with the numbers 400 factorial divided by 100 factorial. Now, the number 400 and 100 comes from the Clay Institute website. The Clay Institute is the one who are giving the prizes for the solutions to these 7 problems. When the problem was posed in the 1970s, the observation was that, let's say a dean has 400 students and 100 dorm rooms. So the question would be, how do we assign these 100 students to these 400 dorm rooms? And then we make a little bit of twist to it like Powerball and says that now we don't want certain students to be in the same classroom. On the Clay website, you do not see that the formula or the number 400 factorial divided by 100 factorial, you don't see it in the form of 400 factorial divided by 100 factorial. But when you make the calculations, look at this huge number that you look at on the bottom. Look at the number that has gone from 292,201,338 when we make the calculation of 69 factorial divided by 5 factorial and multiply times 26. Look how tractable that problem is. We can get our minds around 292 million. How do we get our minds around a number that has 96 zeros? That's what the calculation is for 400 factorial divided by 100 factorial. To date now, when mathematicians see this problem of 400 factorial over 100 factorial, 90%, maybe 99% consider that that problem is intractable. It is not possible to solve that type of problem. Why? Again, it's because when they calculate 400 factorial divided by 100 factorial, they get this number, and guess what? They stop. They can't go any further because they don't have any mathematics to articulate any further than 400 factorial divided by 100 factorial. What three-dimensional mathematics does, and you can see the example that we gave in Powerball earlier, using Powerball, X, Y, Z, A, B, C. Now we see that we can put that formula into its three-dimensional state. Now we can calculate each one of the 5,151 rows of numbers. Now the dean could ask, okay, I want to place 100 students. Where do I place them? Now you can find them. They're in one of these 5,151 groups. That's where the answer is. This n equal np problem is posed as 400 students seeking limited space in 100 rooms. After careful analysis, it is found that this 400 factorial divided by 100 factorial problem is exactly the same as n factorial divided by d factorial. Lottery games and n factorial divided by d factorial calculation. The current belief amongst mathematicians and computer scientists is that no supercomputer in our lifetimes will ever be able to tackle this problem of 400 factorial divided by 100 factorial. This is currently a one-way calculation. Just as 69 factorial divided by 5 factorial Powerball problem was broken into 3 dimensions to calculate a factorial divided by x factorial times b factorial divided by y factorial times c factorial divided by z factorial, three-dimensional mathematics is used to break down this 400 factorial divided by 100 factorial problem into 5,151 groups. This 400 factorial divided by 100 factorial problem is now solvable in 5,151 polynomial steps. The right side of this slide, you can see some data from the 10 groups. The first 10 groups are given. The last 10 groups are given. Any mathematician now can go to the website 3dmathsecrets.com, download the PDF, download the calculations, and make them for themselves. In an earlier slide, you saw a column of numbers that started with 10 and went all the way down to 1, and it added up to 60. Now, the reason that lottery games are mentioned in this presentation is essentially for two groups of people, mathematicians and lottery players. And the reason that it's for two groups of people is because lottery players who play N of N type lottery games are under the false impression that everybody who plays that game will have exactly the same opportunity to win. That is not true. Exclusive access to winnable sets for Powerball, MegaMillions, and EuroMillions is guaranteed for 14 million customers who buy 60 winnable sets of lottery numbers from our 3D Math Secrets website. All these 12 million customers have a 100% guarantee that their 60 winnable sets are not sold to someone else. This guarantee is very important for the integrity of three-dimensional mathematics. In traditional lottery games, when lottery games in the U.S., for example, routinely gets to be $100 million, $500 million, a few with $1 billion, what is important about this 12 million is that these are the only customers that will be able to purchase these 60 sets. If the customer is purchasing a Powerball numbers or MegaMillions or EuroMillions, they're using what is called a random number generator. That random number generator is based on not having a three-dimensional mathematics. That means that when a customer goes and buys a quick pick number, 10, 20, 30, 40, 100 other people can have the exact same number. The random number generator is just spitting out numbers. With 3D Math Secrets, we know exactly where the 292 million sets of numbers are for Powerball, and then when we put those, when we divide them by 60 and get rid of the junk numbers, then those are the numbers that are made available for the customer. Since historical data is showing consecutive drawings from different groups, it is always a good idea to use sets from other winnable groups. The purple section of the curve is where your winnable sets come from. These sets are mathematically proven to increase your odds by 84% to 99%. You can read about the proof on our 3D Math Secrets website. And remember to download your 60 winnable sets today. Now we come to the final slide. Thank you for watching this three-dimensional mathematics presentation featuring our improved odds for Powerball, MegaMillions, and EuroMillion lottery players. You can go to our 3D Math Secrets website at any time and read the mathematical proof. You can also download your exclusive 60 winnable sets today. Three-dimensional mathematics is new. Three-dimensional mathematics is rock solid. Thank you.